with so much wisdom compared to mine, and the ICFP, the way you were so kind one with the other, so much laughing. I said to myself, okay, they are cool, you can do it. But now I'm not sure I can do it. I'm a little scared again. I'm not sure what is that for. Anyway. you do have some as well? Oh, woof. It's terrific. Okay, so let's try to hear these tiles. And I eventually managed to stall 2 months and a half of an engineer. He was supposed to work with some colleague, and I stole it. I stole him. And this was very exciting, because we came up with something we can hear. And this was very frustrating, because I need actually 2 years of engineering instead. And I will present you a demo. It is a little frustrating, because this will be the version 1. And version 2 turned out to be ill-defined, and what pops up is unusable. The problem is that we are trying to understand how to live code with those tiles, and there are still plenty of problems to be solved. And so let's hear what's there. What is this? Virtual experiment. Okay. So first, the idea is to play audio files. And for instance, I take an audio files O, and then I make a sequential composition with another audio file. Let's forget about that. Okay, it will work. Okay, so here is two sequences of guitar, even 3. Let's hear it. So if I put them one after the other, it's a little strange in musical terms, because it's okay, three times the same pieces of music. Okay, you see what I have in mind. I will produce tile out of that, indeed. So instead, here I have pre-tiled the same audio file. So the same audio file, but with distinguished entry and exit. And then I can put that, let's say, 4 times one after the other. And all those tiled audio streams will be played within a loop, so it will loop, so that will be a little cooler. Let's zoom a little. Behind there is an execution engine that allows that do granular synthesis, so it allows to expand or contract audio files. So it is a little comfortable, but okay. And oh, that's better, because we have a regular beat now. Okay, that's cool. I guess only ceux qui ont moins de 20 ans n'ont pas pu connaître. So only the old recognize that this guitar. The youngsters don't know who's that guitar from. But so let's play a little. I have other tiles prepared. So let's put one called "Oh Many Roads." What does that mean? Oh, God damn! I know that guy. That's the funny part, because my colleague at the lab, they are just mad with that music, because I'm training it. And okay, let's make some fork of that "How Many Roads" with the beginning of that second guitar tile. And then Bob Dylan is singing with himself, and well, I can play with that. I can make I'll put some conclusion, so that well, That's a demo. Okay, that's the first demo. I say, it's a lot of fun. Another one, a little more. So here it just illustrates the fact. 10 minutes left. Oh, that's plenty of time. That one just illustrates this idea that let us think a little more about what I am proposing. I was presenting that in front of, so when I present that to theoretical computer scientists, they just found it in love of what I'm doing, and they tell me, okay, your paper shall issue of ICAP. Oh, that's very kind. I made the same talk to SMC in Stockholm last summer, and there were musicians there in the audience, and they told me, okay, this we know to do it with Pro Tools for decades. That's quite true. But what exactly is the added value of this notion of tiling on audio files? When you mix audio file, generally you take two files and then you have to make some analysis of the two files to exactly understand when you want to position one after the other. The idea of tiling is that you sort of internalize into audio file themselves the synchronization point, and after that you reuse it at will. And if you are clever enough, and if this synchronization point corresponds to strong beats, for instance, like in Bob Dylan, then you no longer care of they have to be positioned one after the other, because you just throw them away in the flow of time. And this is the idea of how tile could be used as live coding of music. So and also the product of two tile stream is again a tile stream, so you can iterate. So there is indeed algebra, and I'm sure you understand that, while musicians don't. So the added value compared to audio tool like Pro Tools is somewhat subtle, and only in the long run we will clearly see if this is really convenient or not. A second demo, and then I will stop on that, is the capacity to synchronize a stream processing function on. Okay, I told you it's a little unstable. I have to be careful as well doing that. Okay, so some drum loop here, and I will make it two one after the other. So let's see what. Sorry. So when too loud. So you want me to make it louder? I'm sorry, I'm stupid European. Okay, so that's just two loops of drums, and I want to add an echo on the first one. So I will put here an echo. This echo function has been written in Faust. Perhaps some of you knows that functional language developed by Yann Orlaré, a co-author of what I presented in Lyon. And so here, that echo, I need to tell it that he will get the drum as input. The interface is really bad, so if I do that, I only get the first drum and not the second. And let's see what will be the... So let's put some feedback. Is that so loud? Okay. They complain. Then you show... I am not hearing it at all from here, but... You should hear some effect on the... Yes, we do hear the echo. Do you? So it can be parameterized in real time. I can add the delay value, the strength of the feedback. There might be even another one. And okay, there are other function that can be applied. I just want to put some music with that with that drumming. It will be a little of piazzolla, just to make some. Okay, so this is supposed to be sort of a piece of music, and again, I have. Perhaps what is interesting is that this function I can make it so it is no longer playing when it is no longer there. So it has no longer any effect. And okay, well. This is a little trashy demo. Thanks for your attention. That's the end. And sorry for the neighbors. Yeah. That exists. So you can define. Oh, sorry. So the question is, because there is some algebraic structure behind, there might be some way to abstract, to make some abstraction, and indeed to define some function that would take as argument some other type signals. So this is just true, and this is why we did start with the T-calculus to embed the algebra into what could become a functional programming language, of course. Yeah. So if you just add a lambda, a real lambda to the T-calculus, then you have a functional programming language. The type system we developed guaranteed that it is causal and finite in the past. The next question, and that was on my concluding slide, is okay, for it to be really useful, is that we need a way to dynamically create synchronization length. And in my first submission version, I was proposing something, but that was so much iffy that I threw it away for the final version. And so, for instance, what do you want? You want something. You want the capacity to map a keyboard press to some sound. So you press the keyboard note, and it starts something, and when you end to press it, for instance, it's the end of the synchronization window, and then something can be put behind. There are some causality problems to do that, but this is definitely the issue to think about it and to solve, and as soon as possible. Yeah. Okay.